Okay, so in this final lesson, we're going to be looking at how to find a value for x given a proportion, probability, percentage, percentile, any of those things we can use, assuming we know the mean and standard deviation for a normally distributed variable, and we can use it to figure out the value that that we have. So essentially, what we're going to be given now, instead of finding the area, we're going to be given the area that's shaded, and we're going to work backwards to figure out the x value or z value first. Okay, so we're taking that formula z is equal to x minus mu over sigma and rearranging it. So we multiply both sides by sigma, add mu to both sides, rearrange. We find out that we can calculate an x value by taking the mean and then multiplying the standard deviation by the number of standard deviations the value is from the mean. So again, instead of spending too much time on the theory, let's see how this actually works. So assume we know that the length of human pregnancies measured in days are approximately normal with a mean value of 266 days and a standard deviation of 16 days. We want to use this to try and figure out how long or how short the shortest 10% of pregnancies are. So what we know, it's approximately normal. The mean is 266 days. And we're trying to figure out what value of x would have a probability or a 10% chance of occurring. So it would have a probability of 0.1000 associated with it. So in order to get started, we need to figure out what z-score has a probability of 0.1000 associated with it. So we're going to go to our z-score table. So because we're given a probability, we're going to be looking up in the middle of our chart now, and we're going to be looking to figure out what's the closest value to 0.10000 I can find. 0.1000 doesn't appear exactly, but we can get pretty close at a z-score of negative 1.28. So let's go back and write that. So we know that the probability that z is less than negative 1.28 is 0.1003. And that's as close as possible that we can find. So what that tells me is that my x value, again, remember this formula we said we were going to use? My x value is going to be my mean, which is 266, plus my z-score, which is negative 1.28, times my standard deviation, which is 16. Okay, based on order of operations, you're going to want to make sure you do the multiplication first, then add it on to the 266. This comes out to 245.52 days. And so what that means is that, okay, with the information we have on hand, we conclude that the shortest 10% of pregnancies are less than 245.52 days long. Okay, so again, just to go back through the steps that we went through in order to solve that problem. So we did a quick sketch to figure out where our x value might be located, right? We were given a percent, so we had to turn it into a probability, right? We figured out the z-score closest to that probability. And then we plugged our mean, standard deviation, and z-score into a formula to figure out the x value that would solve the problem. Okay, great work. So let's try a practice question, try and do this again. So same information. Again, we're going to stick with human pregnancies, and we know on average, the length is 266 days, a standard deviation of 16 days. And so what is the length of pregnancy in days for women in the 75th percentile? And I will just draw you a picture to get you started. So when we say the 75th percentile, right, what we mean is that 75% of the data, right, is lower than that particular value. So there's a little bit of a picture to get you started. Pause the video and give it a go. Okay, so it turns out that the length of pregnancy for women in the 75th percentile is about 276 days long. We had to look up the probability in the table and find the Z-score closest to that. So a Z-score of 0.67 has a probability of 0.7486, and that's about as close as possible. And so then if we go 0.67 standard deviations above our mean, we get our answer of 276. Okay, if you have any questions, don't hesitate to ask. More examples will be done in tutorial. That wraps up our video lectures for the semester. Good luck, and it's been great teaching you this semester. Take care. Bye.